ABM INC Mask Aligner. This mask aligner can handle up to 6-inch wafers, and currently it is configured for 4-inch wafers and 5-inch masks. The mask is to be mounted on this mask holder bracket. And currently it is already mounted and secured. The unit will be shipped without the mask frame in the bracket for shipping purposes, and also the substrate holder will be disconnected from the substrate holder post. There are 3 connections on it for contact vacuum, substrate vacuum, and self-level check vacuum. The self-level check vacuum is to be used when leveling the chuck parallel to the mask, and while leveling, the button in the front, the chuck leveling button is to be depressed, so that when we press it, the chuck becomes free, and once you release it, it is locked in that position on the vacuum condition. The unit requires about 25 inches of vacuum. We have a gauge for system vacuum and system pressure about 50 psi, and also nitrogen about 10 to 15 psi. Load the mask frame. There's a vacuum line for the mask vacuum, and then so right now the mask is held under vacuum, and I'm going to load a substrate. So there are substrate orientations, tiny little brackets on the substrate holder, which will help to position the substrate So once you place the substrate, turn on the substrate vacuum, and then lower the mask frame. The control panel has a bunch of switches and indications. This one, the yellow switch for the auto manual, which is in manual mode, all the sequence of cycling the lamp housing to the aligner is to be done manually. But in auto mode, once you select auto mode, the nitrogen flow will turn on, and then the contact, more exposure is to be done. Press the contact vacuum. There is a vacuum generated between the substrate and the mask. And there's an adjustment knob to adjust the contact vacuum level. You can select about 22 or 25 inches contact vacuum for hard contact, and about 15 inches mercury for soft contact, whatever is the desired value. Once you set the contact vacuum level, the unit is ready for exposure. But in order to do the alignment, turn off the contact vacuum and purge the space between substrate and the mask with nitrogen. To level the chuck and the substrate holder parallel to the mask, rotate the Z-axis knob counterclockwise to lift it up, and then once it touches the mask evenly, release the push button. And for alignment, you can bring it, the chuck can be brought down by rotating it clockwise. And now the X and Y knobs can be adjusted for X and Y motion, and the theta knob for rotating the chuck. So after the alignment is done, rotate the knob counterclockwise to 0 position again, and then turn on the contact vacuum. Then press the cycle button. The microscope will move away from the aligner and the exposure will start. The exposure time is controlled by the timer, Omron timer, which can be controlled from 0 to 999 seconds. There is also a manual expose button. By pressing that, the shutter could be manually opened or closed. Once the exposure is finished, the microscope will lift up and the mask frame will rise, and the vacuum under the substrate will be turned off. To repeat the cycle again, replace the sample, turn on the substrate vacuum, and lower the mask frame again. There are 2 buttons on this microscope arm, microscope manipulator arm. By pressing them, you can move the table in X and Y directions. A fiber optic illuminator is used for illuminating the substrate, which helps to align the wafer. A Nikon stereo zoom microscope is provided, SMZ 645 model. The unit comes with a Nikon stereo zoom microscope, model 645. The unit will be included with at least 2 sets of eyepieces, 10x and 20x. And if the buttons are not pressed, the microscope cannot be moved. At any point of time, if you want to stop the power supply to the system, use the emergency switch on the right hand side or the system power off. In order to do the proximity exposure, the contact vacuum button should not be turned on, and using the Z-axis knob, the substrate to mask gap can be adjusted to the desired level and proceed for exposure with the cycle button. The unit is controlled by an PLC, and the PLC is inside the unit under the table, and it is accessible by opening the back panels. Okay, I thought of pulling the UV lamp is powered by this illumination controller, 2105C2 controller, currently configured for 500 watts UV lamp. The unit can be used in constant power mode or constant intensity mode. Right now it is in constant power mode. I set it about 450 watts. If the unit is to be used in constant intensity mode, slide the switch to the CI mode and intensity, and there are two channels, one for 365 nanometer, channel A, and channel B is for 400 nanometer. Using an external meter, adjust the calibration knob so that only when the shutter is open, the meter will indicate intensity in milliwatt per centimeter square. Adjust the calibration knob to tally with the needle. By adjusting this calibration knob, we have to match the external meter to this value. Example, you can change by moving the calibration knob. I'm able to change the reading. So this reading should match the external calibrated meter. Then we can adjust the set knob to the desired level. By adjusting the calibration at about 450 watt, we can set the power level up to 550 watts maximum, and the lower value could be as low as 400 watts. Similarly, the channel B can be adjusted. The unit will be shipped with the lamp out of the lamp housing. The lamp, when it is to be installed, should be installed with anode in the down position. The anode is marked on the metallic electrode. There is the aluminum heat sink that goes on the anode. Before connecting the electrically, the heat sink should be used. The unit comes with an exhaust fan connected, which is powered from the lamp power supply, and there is no feedback mechanism to check if the fan is running. So the operator must verify the fan operation once in a while. Otherwise the lamp housing will get heated up. The substrate holder can also handle 3-inch wafers. I can get the full vacuum level at 25 inches by turning on the substrate vacuum. And here's a section of a 3-inch wafer. You can also use a section of a wafer. In order to keep the substrate parallel to the mask, the smaller than 4-inch wafer pieces, they have to be placed approximately at the center of the chuck. Otherwise, it will cause problems by creating a wedge gap between the substrate and the mask.